Hello, and welcome to Construction Tech, presented by House Accelerator, a catalyst of zero carbon building. We're happy you're here. We welcome all comers to our exploration of how to slash the greenhouse gas emissions of our buildings and make them more resilient to the extreme temperatures, wild weather, and grid insecurity caused by climate change. With our co-hosts, Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce this weekly series to dive into the details of passive house construction practice, with a technical focus on technique and technology in the field. New to all of this, please visit the Passive House 101 section of our website to get started. With that, please enjoy Construction Tech and pose your questions in chat for the discussion session following the presentation. Thank you. All right, welcome everybody, and thank you for being here for Construction Tech tonight. And we're very excited to have Micah Gold-Markel of Solar States here to present about solar education for high schoolers. So with that, co-hosts, please take it away.
Oh, thank you so much.
Thanks,
wow,
Micah. I'll kick it off to you. We just do a quick little introduction. I'm Kevin Brennan. Brennan Insulation Air Tightness. Welcome to the episode 1 of Year 2 Tech Tuesdays, where we're going to get quite nerdy and technical about solar and education of the future to tomorrow. So I'm really excited that it's happening. Only a few states down, 2 states down from me in Philadelphia. I hope it makes its way up here to New York City, because we need to train the trades of tomorrow about tomorrow's technology. And passive house and solar go together like peanut butter and jelly. So I'm going to pass it off to the next co-host.
Oh, making me hungry, Kevin, on Tuesday night or Wednesday morning, depending on where you're coming from us. Micah, hold on. We will get to you. We're excited to have you. November is about to wrap up. Some of you might be shaving tonight or tomorrow morning for the lovely November. So again, great cause. And then we're into December, the last month of 2021. Where did this year go? I hope that you've enjoyed all of the construction tech events that we've put on this year. And we're getting ready for 2022. So if you think that you have a presentation that you would like to connect with us, let us know. We want to share, we want to collaborate, we want to grow, we want to teach. We just want to make sure that we're all having lots of fun. And that being said, over to you.
Awesome, Kevin. Awesome, Sean. Mark Willey here. I gotta say, real excited for the second year as well. It's nice to see so many awesome, familiar faces. We have some educators in the audience, and shout out to Matt Bloomquist there. So if the rest of the folks that are on here can do us a big favor and in a couple of days take this presentation and share it with their community networks and educators so that they could follow this example and get her going. So speaking of get her going, I'm thrilled to have Solar States here tonight. And Shannon, over to you.
Oh, a whole new year with the mute button. Here we go. Well, thank you, Mark. Thank you, Zach. Thank you, Kevin. And I'm really excited to be here tonight. I'm Shannon from Sanderson Design, and I'm zooming in from New Hope. And I am really close to Philly. So near and dear to my heart is Solar States and tonight's guest, Micah. So he has been running a successful software business for 16 years before he got into what he's doing now. And he was inspired by Van Jones to start a sustainable energy education and economic development business using solar energy as the glue. So he founded Solar States in 2008, and it's been a positive environmental and economic change ever since. They're committed to solar energy. They're a B Corp. And they're going to show you how they're working with local schools to teach kids and get them involved in the workforce development we're all waiting for. So thanks for being with us tonight, Micah. We appreciate you coming.
I was so hyped up by that intro that I just wanted to jump in and start talking. I was like, oh man, this is awesome. This thing is like rocking. I'm ready to go. Thank you so much for having me this evening. And it's really great and a lot of fun to talk about solar education. In the solar industry, as a whole and some of the exciting work that we've been doing. I have to start by giving a shout out to some of our partners, the Philadelphia Energy Authority. Oh my goodness, we really wouldn't be here without them. Philadelphia OIC, as well as the ECA, and that's the Energy Coordination Agency here in Philadelphia, all about weatherization. Our good friends at Bright Common as well. And then the School District of Philadelphia, and I have my man Jordan Crowley here as well. He's our teacher at Frankford High School. So some of you may see the image, or may have seen the image that was behind Shannon of our school cutting the ribbon at the Frankford High School Solar Lab. And let me tell you, this was an amazing experience, okay? First off, we've been waiting for so long to open this lab. We had planned to open it last year. Of course, this strange thing happened called COVID-19. Our whole idea of starting the school year off teaching in this like fabulous lab, we had spent all this time designing it, putting it together. We've got this mock roof in there. We've got all this cool technology. We've got solar panels. We've got racking. We've got batteries. We've got inverters. We're like, we're going to get these students really pumped up. They're going to be like totally hands-on. That's like the whole goal of this. As you'll see a little bit later, we've done all of this work on creating a curriculum around this. This was also funded in large part by the Department of Energy, gave us a grant to do this solar as a vocation curriculum for the state of Pennsylvania. It's incredible. It's called Bright Solar Futures. I'm going to share some of it, actually a little sneak peek, because we're not quite there publishing it yet, but it's going to be online and available for everyone to use. Over 1,000 hours of solar education, so that we can have schools in the state of Pennsylvania and any state throughout the union have solar installation as what's called a CTE, or Career Technical Education track at their high school. And the idea here is that we want high school students to be able to come out if they choose to not go to college, which, let's face it, not everyone's going to go to college. You know, I want people to go to college. I think it's a great choice, but not everyone is going to do it, myself included. And we have to have great jobs in the green collar economy waiting for these folks. And how can we do that? That's through solar education at the high school level. And I like to say, if we can do something here in Philadelphia, then we can do it anywhere. This is one of the most challenging environments to get things done. We've got a huge school district. Unfortunately, we've got a lot of issues with poverty, with attendance, you name it. We really deal with it. I'm sure Jordan, you know, he can pitch in and say, hey, you know, there's a lot of issues that come up, but we're working our way through this, and we're figuring out a way to make sure that these students are exposed to solar and they do know the vocation of installing solar. And that's really different, you know, from, I think, a lot of the classwork that's out there. I myself, when I looked for classes, you know, got some hands-on stuff, but it wasn't the focus 100%. A lot of it's theory. Now, we want students to learn theory, and there's a lot of theory in this class, but there's a focus on getting hands-on, and it's sort of the reverse of what you would normally think of. Usually, you sort of learn the theory first, right? You say, well, energy comes from here, you have to do this, you have to do that. You have to understand how energy is converted from one source to another, how it's used, this, that, and the other, all of that stuff, extremely important. But we were finding that a lot of the students in inner city neighborhoods, which is where I'm from, weren't grasping on to that theory right away because it didn't connect with their everyday lives. And so we wanted to find a way to make that connection, to make it so that, you know, hey, how can we make this relevant to their everyday lives? And boom, this is what we're doing. We decided to flip the script, to start with hands-on, to say, hey, this is how you put this stuff together. I remember one of my clients once said, solar, I get it. It's like adult Legos. I said, oh my goodness, that's kind of right. You just kind of snap these things together and they work. And then there's this whole beautiful theory about why and what we're doing. So there's a lot to talk about this evening for sure. Shannon, Should I just keep it rolling from here and then I'll pass it back to Zach?
Yes.
All right.
Great kickoff. And thank you, Jordan, for joining us. I know we've got you here for a limited amount of time. Everybody give Jordan a warm welcome. And yeah, feel free to share your screen. You should have permissions.
Okay.
And I dropped your LinkedIn connection into the chat, so you'll probably get a lot of new friends after the beginning of tonight.
Oh, wonderful, wonderful. Well, one of the things that I'm super excited about, as I said, is the classroom. But before I get to the classroom, I want to talk about how we actually got into the classroom. And that's really through Jordan's perseverance. The first year was a total curveball. I mean, it was like nobody expected this COVID thing to happen. We had written, as I said, this fairly in-depth syllabus with this lab in mind, right? We're thinking, okay, we've got a solar lab. How can we utilize it in every piece of our coursework? What can we do? How can we make this the most dynamic possible, right? And then it all changed at the, like, all of a sudden we got told, okay, nobody's going into the classroom anymore. And we're like, oh, wait, what? All of this stuff is gonna have to go out the window, and we're gonna have to think about how it can all be done online. And none of us were even remotely ready to consider that. I mean, it was like a total shock to the system. But we had a really innovative teacher, and that's where Jordan Crowley comes in. And he really started looking at the syllabus, found that it was over some of the students' heads, unfortunately, and that it wasn't connecting, and had to just do, what we call in the solar industry or the football, a flea flicker. He decided to change the play up. Instead of running the ball, he was going to toss it back to the quarterback and go deep. And he really tried his best to engage the students online. Now, keep in mind, these are students, these are teenagers who are not required to turn on their cameras when they're on the Zoom class. Zoom class is really the only thing that we can do. And so, my goodness, Jordan had to sit there and figure out ways to engage the students online. And he managed to do this for an entire year in such a way that we got students back in year 2, and we were able to open the classroom up. And so this year, we started having students in the classroom. Hopefully you can see an image of the chalkboard there, of us wearing our PPE. That's where we start, right? We want to lay out all of the safety gear for the students. And we don't say, hey, this is safety gear, you got to put it on like this and do that. No, what we try to do is say, look at this gear. What do you think it does? How do you think it works? How does this stuff go together? Because we want to get students really imagining things. And sometimes they come up with things that really surprise you. And you're like, oh my goodness, well, this isn't used that way, but maybe there's a new product there. Maybe there's something that can be innovated on that, hey, you could start a new business doing. My goodness, wouldn't that be amazing? So this isn't just about being worker bees per se, but it's also about being innovators. And I like to say to students, when I come into the classroom, this is a problem. Climate change is a problem that we're solving through solar energy and through non-carbon emitting energy sources. But guess what? There's also a lot of money to be made. And that's what connects with a lot of these folks from the inner city. Yes, climate change is a big problem. Yes, I feel it is going to be the problem that is going to be facing our children. But people have immediate needs that need to be met, especially people from low-income households. So, they come into it and they think, how am I going to put food on my plate tomorrow? And I tell them things like, guess what? At Solar States, if you know nothing, when you're starting off, you're getting paid $16 an hour. You're going to get a 401k and healthcare. Guess what? That makes a big difference. And then when people see that they can come through the Solar States family and really learn and progress and grow, it makes all the difference. So that gets them started in thinking of this. Then we get in really innovative guests like the wonderful folks at Enphase who come with this truly incredible truck. I mean, the Enphase truck is the coolest thing in the world. And I have to give a shout out to my man, Andrew at Enphase. I met him at a training. I said, Andrew, man, this would be great to bring to our classroom. And Andrew goes, oh my goodness, I would love to do that. I would love to bring this out. And I said, Andrew, man, this would be so special for the students. It would be super special. So Andrew picked a day, came out in the morning, and guess what? It's a COVID-friendly classroom. So this is another technique that I think educators can use as they're thinking about, hey, COVID might limit our classroom time. How can we meet outside, bring the classroom outside? And so having companies come and present using their resources is a great way of having an outdoor classroom, and something that I wish we were able to think of sooner to engage students in doing this. And as you can see here, Andrew was really psyched up to meet a lot of the students. You know, all the students are standing around, they're all serious. Andrew's the one like this, you know, the only adult in the whole team is the one making, you know, the hand symbols and everything in the picture. But this was really cool because it got to give the students exposure to not only the concept of microinverters, how they work with solar. For those of you who might not be aware, traditionally in solar, we've used string inverters where you have a whole string of solar panels, and then they go down to a single inverter where that DC current gets inverted to AC, which gets used in your house. Well, Enphase innovated on this, and they came up with a microinverter that sits underneath each individual solar panel on your roof so that you can get power output individually. And this is neat because it helps to comply with new code for what's called rapid shutdown, where you have to be able to shut off each individual solar panel on a roof. But it also means that you're dealing with AC current instead of DC coming right off of the roof. Very cool concept. But how does this work with batteries? Because we know traditionally that batteries output DC current as well. Well, Enphase came up with a really creative solution where they put their microinverters and paired them with batteries as well. And those are special microinverters that can now take AC current and convert it to DC. And then when the batteries need to be discharged, they can invert that DC to AC to be used in your house. And we're seeing huge innovation in this space with the the release of the IQ8s. Actually, you can have a microgrid right at your house, right from solar. You actually don't even need batteries. It's amazing. It's mind-blowing. One of the biggest problems that I've had with clients is they say, okay, so I'm getting solar. So when the power goes out, guess what? I'm going to be the only one on the block with power. And I say, oh, no, you have a grid-tied solar array. So actually, when the power goes off, your solar goes off. I'm sorry about that, you know? And one of the reasons for that is because, hey, you know, if you're creating power that gets pushed back onto the grid and there's a power outage, well, if there's a line person working on the line there, they could get zapped by power coming back on the grid. But Enphase has come up with a way to exactly meet the loads of the house and to isolate the house from the grid such that solar can stay active, form a microgrid right at your house so that when there are these power outages, you can still get some power. This is what these students were learning that day. I mean, it's pretty advanced stuff and they're getting right into it. So I was really, really excited about that opportunity. And I think there are lots of equipment vendors out there that can, you know, enrich the classroom. Here's Jordan with the class. We actually were lucky enough to have the mayor and a lot of city council out because this was one of the first classrooms of its kind in the entire state of Pennsylvania at a high school. Usually these are sort of outside of schools, right? They're independent education organizations. This is a public high school right here in Philadelphia. Now, you know, if I didn't say there have been some significant challenges with this, I'd be lying to you. You know, students learn at their own pace. You really have to be open to where they're at. And there are lots of different levels of students. And actually, I was reminded of that a bit today. We had the students in for 2 hours. We were actually teaching them how to bend conduit, 1/2-inch EMT conduit. Jordan and I were standing there with the pipe bender, showing them how to do, 90s and saddles and all sorts of different bends, offset bending of conduit, and some of the students were really getting it right away. Some of the students were just destroying the pipe, and they're pulling back and they're not quite getting it. And we had this one kid walk in, he was an hour late, and I'm all frustrated. Hey, you're late, you're behind. He comes up, I say, I need you to, bend this stub up right away. He looks at the instructions, he gets it, boom, he bends a perfect stub up, like right out of the gate. It's one of those things where, some students are going to be really fast to grasp this stuff, and other students are going to need to take their time and get the tactile feel for what we're doing. And our job as educators is to meet the students where they're at and figure out a way to make this a challenge for everyone and to make this exciting for everyone involved. And I'm very happy to say that we have women participating in our class who were interested in getting into the solar installation field right away. I was really hoping, I was saying to myself, man, I hope some women, sign up for this class. I was a little bit worried because traditionally, let's be honest, construction has been very male dominated. But we've seen a lot of women have interest in this field, both at Solar States and now at the school level. And I'm really excited to see a revolution of women coming through the trades to really diversify the industry. Not only that, we're seeing a lot of interest in low-income neighborhoods. We recently installed 50 LMI, low to middle income solar installations in the city of Philadelphia through an innovative financing technique with the Philadelphia Energy Authority. And that was a huge success. So we're really, really excited about the future of solar. A little bit more about Solar States and the class trainings that we do. We have several labs that are set up. As you know, we have one at Frankford High School, but we also have a training lab at the ECA and Philadelphia OIC for young adults who want to get into solar. Hopefully now you can see some of the images. Again, we have like a little locker room where you can get your PPE on. And even on our training rooms, we like to say, look, you got to treat this like real life. You got to, wear your PPE, your fall arrest systems, your hard hats, get your gear on. And we have training facilities at the ECA and at Philadelphia OIC. And the goal here, again, is not just training for training's sake, but we hold job fairs at the end of all of our classes. We hire pretty much exclusively through our programs. And I'm going to talk about that a little bit as we go down the list here. So we've developed a much shorter curriculum. I explained the Bright Solar Futures curriculum is over 1,000 hours, high school level. We also have the Find Your Power curriculum, which is more of an 80-hour, and that can happen over, 3 to 4 weeks. Sometimes we stretch it out to 6 weeks, where we're doing lots of trainings with young adults. And we pre-qualify people simply by saying, hey, are you interested? Do you want to learn this stuff? And then we ask, are you able to lift up a solar panel, lift a ladder? We do a little test with that. If you can do that, then we're going to take you in and we're going to make sure that you get the skills needed to have a jump start on getting into this industry. Well, what does that mean? That means you not only are learning the field stuff, and we have certifications for making what's called field-made connectors, MC4 crimps, where you're doing some of the actual hands-on work with solar. We also have a little certification for making sure that you understand electrical safety, that sort of stuff. So we make sure that there are little checkpoints along the way to ensure that people are learning the skills they need. But then we also take a more broad look and we say, hey, would you be interested in becoming a NABCEP associate? And that stands for the North American Board of Certified Energy Practitioners. It's a terrible name, I won't lie. It's such a mouthful to say, NABCEP. It doesn't even roll off the tongue, but it is the gold standard for certification in the solar industry, right? And they do an incredible job of making sure that people are ready to enter the solar industry. So when you have that NABCEP Associate's credential, it means something. And it's also a step to getting your NABCEP PV installation professional. That's the certification that I have. It's a very difficult test to take and to pass. But taking that associate's quiz is something that we bake in to our classes so that students can graduate with a credential. The other thing that we try to ensure that students have as they're coming out is at least a bare minimum of their OSHA 10 certification, because you need to have safety on the work site. Philadelphia requires anybody who's stepping onto a work site to have that OSHA 10 certification as a baseline. And if you're going to be a 4-person, then you have to have at least an OSHA 30 certification as well. And some of our students end up going for that as well. So what you see on your screen right now is a map of where our employees live in the city of Philadelphia. And this is something we're very proud of, because our mission is to be the on-ramp to the green collar economy for inner city Philadelphians. So where you see a dot, that's where one of our employees lives. But where you see a logo, either OIC or PowerCore PHL, I'm not sure if I gave them a shout out, but PowerCore PHL is another very important partner that we work with here in Philadelphia. Then that means one of our employees has come through the program that we ran either with PowerCore or OIC, and they're now working with us, and it shows the neighborhood that they live in. So we're really focused on making sure that the jobs are being distributed equitably throughout the city of Philadelphia. And that's really important, because for many years, when I started, particularly 13 years ago, hey, the solar industry was very white male dominated. We need to make sure that these jobs and everybody is being included. And that goes back to our mission. And our mission is to be the on-ramp to the green collar economy for inner city Philadelphians. But that's based on Van Jones's book, The Green Collar Economy. And I don't know if anybody here has read this book. It's an incredible book. Came out about 13 years ago. It inspired me to start Solar States. It inspired me to have this mission. And I got a chance to really talk to Van Jones as he was going on a book tour about this. And in his book, he says the green wave can lift all boats. And that line just got me. It got me in the heart. I said to myself, my goodness, isn't he right? The green wave can lift all boats. It can be something where we all prosper together. We all have good paying jobs together. And he said, you know what? This change in our economy, it's not a nice thing, it's a necessary thing. It has to happen. And if it happens in the way that previous economic revolutions have happened, we're going to fail, because it can't be just centered with some folk. This is an environmental disaster that could happen. We all have to have a part in this. We all have to be responsible, and we all have to benefit. And that's what our goal is here with these training programs, is to make sure that people have that opportunity. That's what our curriculum is really geared toward, is saying, hey, if you're interested in this, we want you in this industry. We want to make sure that you can find a job here. And the solar industry, one of the reasons why the solar industry is what it is today is because it's fast growing, right? It's super fast growing. And much like passive house construction, many years ago, I'm sure barely anybody heard of passive house standards. I mean, who knew, right? Who knew about insulating your house, making it super airtight, and all of these concepts that are so important to conserving energy. But now, as we're becoming more aware of this stuff, more people want to do it, more jobs are available, and we need more people who are ready to come out and execute really important and detailed plans for houses. And that's where it starts. It starts at the planning level, it starts at the education level, and then we take that and we go out in the field and we execute. And that's what we're all about. You can see this is one of our classes on top of the Crane Arts building. This is an installation we did 11 years ago. It was one of the largest in the city of Philadelphia, okay? And it's 444 solar panels on the roof of the Crane Arts building. And I take the students up there so that they can see the sea of solar panels on the roof. And then I say to all of them, okay, everybody, turn around. And they turn around and there's this amazing view. You can see it a little bit in the background, just incredible view of the entire city of Philadelphia right there in the background. And when you look at all of the roofs, there's almost no solar on any of them. And I say, look at these roofs. What's missing? What's missing? And they all say, oh my gosh, there's no solar on any of them. I go, I feel like an oil man who's surrounded by oil. There's opportunity everywhere. They all light up. It's like, oh my gosh, there is opportunity everywhere. Each one of these roofs could have solar on them. And oh my goodness, what? And then you get that conversation, you get that inspiration started, you get it going. And then they all want to get involved. They say, okay, all right, I get this. There's a lot of opportunity. How do I get involved? Why, where do I start? And then we start talking about the economics and how it all works. And they're tuned in from that moment. Another piece that I like to bring to these students is to connect it to their everyday lives. Talking about energy and environmentalism in the abstract can be very difficult for some people. And so if you connect it, if you say, okay, what kind of music do you like to listen to? And everybody names the type of music they listen to. Okay, now, what do you listen to it on? Okay, I listen to it on, some sort of electronic device. And at the very basic level, what does that device need to operate? It needs electricity. It needs electricity. Okay, where does that electricity come from? Well, there's a lot of coal-fired power plants in the state of Pennsylvania. Guess what? Particulate matter in the air from coal burning is one of the #1 causes of asthma. Who knows somebody with asthma? Almost everybody raises their hand, right? Everybody knows somebody with asthma. Well, isn't it crazy? Have you ever thought about the thing that you love doing, listening to this music, using electricity is making us sick, literally. It's kind of crazy to think about. There's, this coal being burned that's giving us asthma, and just because we love to listen to this awesome music. But there's another way. We can solve these problems in a brand new way. And sometimes those are the hardest ways to solve problems. We know how to deliver electricity to a lot of the United States. We know how to generate a lot of electricity, but now we need to think of a new way of solving this problem that's already been solved. And that gets the creative juices flowing in the classroom. That gets these students thinking about how it's connected to their lives. And as you can see in this class, we have women, we have young men, we have Black folks, Asian folks, white folks, folks of every walk of life, low income, wealthy, college educated, not college educated, you name it, we get them from everywhere. And that's one of the things I love the most about our programs is we're bringing diverse groups of people together who are inspired by solar to get into the industry, to make sure that they can get a great job going forward. So I've talked a little bit about the curriculum that we use at the high school level, and I'd like to share a little bit of the syllabi that we wrote just for year one. It's a very long curriculum, over 1,000 hours, so I'm not going to share all of it. Let me see if I can find the screen to share here. Let's see. This is the year one. This is a 3-year, 1,000-hour course. So this will give you an idea. The syllabus is an outline, but each one of these lessons has a lesson plan to go with it, and then a sort of description to start at the very beginning. So as you can see by the course description, Bright Solar Futures is demonstration-based and hands-on training. That's really the key to the curriculum that we've worked on with our partners. And you can see that year one, we have these goals for the students to be able to describe the construction and solar safety components, tools, safety plan, and so forth. Now, we worked with our partner at the ECA to also integrate weatherization and energy efficiency, because let's not forget, solar is the tip of the pyramid, right? You want to have a house that's super tight. I mean, I'm talking to the converted here, right? Passive house people know. You try to use as little energy as possible, and then you get that energy from renewable sources, right? So we want to integrate, some of these weatherization techniques into here so that people understand it's not just about solar energy and wasting tons of energy. You want that super tight house that sips energy, and then you want that energy to come from solar or some renewable sources. Now, In our particular instance, we also wanted to develop life skills and professional skills for the students. It's very important because they can't just go out there knowing about solar, but not be able to convey what they know to their future employer. You know, how to understand how to do an interview, how to present and say, hey, I know this stuff, how to be confident with themselves as they're presenting themselves to future employers. So week one, as I said, we start with safety, and these are all links to lesson plans, ladder safety and PPE, personal protective equipment, introduction. Again, we continue with that. There's a lot of education about tools too. You know, it's funny, when I get into the classroom, every student swears, oh, I know how to use a drill. I know how to use a hammer. I know how to do that. And then you have them start hammering, they're bending 30 nails in a row. And you're like, dude, it's not, no, you got to use a hammer. It's about the wrist motion. Keep your eye on the head of the nail. There's a proper way to use a drill. There's a proper way to use a hammer. We go through all of that stuff, you know, and we just don't just assume that everyone knows what they're doing. It's really important to have a mock roof in the classroom. We build all of the mock roofs in our classrooms so that you can have a 6-panel solar array set up. And now the really unique thing about the Frankford classroom is we also have an electrical wall that's energized, and it can be energized or shut off so that the students are safe, but we can energize it so that we can actually turn the solar array on indoors. The goal, we're going to buy some lights indoors, is to be able to fire up that solar array and actually go all the way through commissioning the solar array with batteries in the classroom. I think that's going to be a very unique experience for a lot of the students. So we not only practice on the mock roof, but Philadelphia is a town of row homes where there's a lot of flat roofs, and ballast weight systems where concrete blocks hold down the solar rather than having mechanical attachments hold it down are very popular because there are no holes in the roof. So we not only go through how to install on a more suburban style pitched roof, but we also do flat roof ballast weight training as well. So then we want to make sure we step back for a moment and students have some time to really understand the design and the interconnection requirements for solar. And then we step back again and we say, okay, let's talk about electricity basics and the code book and why that's important. And again, we kind of, you know, use that time to build up the general skills. So we start hands-on and then we go theory, which is kind of the reverse of the way a lot of folks do it. We go through racking systems. Then we also talk about other roles. You know, we are heavy on solar installation, but we want to let people know, hey, there's sales, there's site surveys, there are people who fly drones who are part of this industry. There are lots of roles. If you're not into construction, you can still play a very important role in the solar industry. And we spend more time on our electricity basics. Then we go over the different types of solar. There's grid tied, there's off-grid, you know, there's hybrid systems, all sorts of stuff that's out there. As you can see, there's weeks and weeks of content here. We go into earth science basics, solar fundamentals, site analysis. So site surveyors, that's a role that we frequently need to hire for. You're not doing construction, but you're going out, maybe you're flying the drone, maybe you need to take apart the main service panel so that you can photograph the condition of the electrical systems in the house. These are all things that we're training our students to do. Understanding tilt and azimuth and how they affect production, the different interconnection types, line side versus load side. And then we do some assessments and practice tests. Now, again, traditional school, you'd sit there, you'd take your test, you'd be very nervous. I know Friday's coming up. I got this huge test. I got to study. I got to do this. I got to do that. Well, we wanted to change that rubric. We wanted to change that feeling. So a lot of what we do is assessment-based testing, where you're getting hands-on. Can you install the flashing properly? Can you make this field make connected properly? That's what we're testing you on, not necessarily, hey, can you write the right answer or pick a multiple choice answer on a test? So it's really much more hands-on. Then we go into weatherization. And again, this is where the ECA really did a lot of work. You can see air sealing and insulation, auditing, applying, so that your house is just sipping on energy rather than hogging it up. You know, there's a big difference between having a 50 panel solar array and a 10 panel solar array. And I'm always inspired. And I tell my students, you know, I remember the first time I went out to New Mexico and I saw these things called earth ships out there. I mean, these things are incredible. These off-grid houses, they're super insulated. They're in the ground, right? They use southern facing light. I thought to myself, wow, they're off-grid. They must have these huge solar arrays, right? I go, like, these houses have 5 solar panels on them and that's it, because they're so efficient. They use DC refrigerators and, you know, LED lights, and they just sip on energy. And it's incredible. It's incredible because they don't have huge heating and cooling needs because of the way they orient the house and the way they're insulated and so forth. So I make sure that students know it's not about necessarily more. It's about how do you conserve? How do you use what you have as wisely as possible? Okay, so as we go through this, we review, we go through the different system types, and we make sure that students get exposure to lots of different roles here. And then you can see some suggested time allotments at the end. I don't want to take you through all 3 years of this. There's a lot of content here. If anybody is interested in learning more, I'm going to put my email in the chat so that, you know, if you do want access to this when it comes out, I'll make sure that you get a copy. You know, that's kind of my spiel for now, so to speak. I was told too that you have a tradition of thanking a mentor. And so I want to take a moment to thank a mentor of mine. And that mentor's name is Ron Celentano. Ron is the godfather of solar in the state of Pennsylvania. Ron taught me basically everything that I know about solar. And there's a real funny story I love to tell about how important Ron has been to me in the starting of Solar States. I told you about that solar array at the Crane Arts that I take students to. Well, that is actually owned and operated by Solar States. So we did what's called a PPA, a power purchase agreement, where we own the solar array and the building owner buys the power. And we did this agreement, right? And you know, I had to basically beg, borrow, and steal to get the money together to do this project. I mean, it was incredible. I went to bank after bank. I got turned down. I ended up borrowing. I did a letter writing campaign to friends and family, borrowed $250,000 through $5,000 to $10,000 loan commitments, got half the money. And then I had grant money for the other half, but I had to spend the money first. And I went back to the banks and I said, I've raised 250. I have grant commitments for the other 250. Can you loan me the money? The bank still said no. They said, no way, we don't lend the money. And so I was ready to give up. And then I met this guy who was actually in private equity who had just installed solar on his house. He goes, I get this. He goes, I'll loan you the 250. I'm like, whoa, you have that money? He goes, sure. He goes, but it's going to be 16% interest. I was like, oh my goodness, this guy's a shark. But we made it work. We made it work, and we got that project financed. And we got the grants in. We didn't have that 16% hard money out for very long, and we got it all done. But the project to repay the loans over the 10-year period, we were relying on what's called SREC revenue, or the solar renewable energy credits. Okay, and at that time they were worth, you know, $360. They were really, you know, selling for a high value, and we were getting, you know, $40,000 in a year in SREC revenue. And I was thinking to myself, wow, this is going to make money. I'm actually going to do this. And I remember the day Ron called me up, and Ron said, Micah, you've got to find somebody who's going to do a future strip for your SRECs. I said, what's that? He goes, that's when you get a guaranteed price for your SRECs, but it goes out 2, 3, or 5 years. And it's going to be lower than what they're selling at now. I said, Ron, I don't want to lose this money. He goes, trust me, the SREC market, as much as it can go up, it can go down too. And he found me a guy who was willing to buy my SRECs for something like, I don't know, 3 or 4 years at $280 in SRAC instead of $360. And I kept saying to Ron, I'm losing like this money here, man. Are you sure I should sign? He goes, Micah, don't gamble with your future. Sign the contract. I did it. 3 months later, SREX crashed all the way down to $50. I would have been completely ruined if it hadn't been for Ron's wonderful advice at that time. So I got to give a big thank you to Ron Celentano. He's been incredible with policy and just making sure that the state of Pennsylvania, as well as the United States, has great solar policy. He's constantly pushing for it. So thank you so much, Ron. And with that, I'd like to hand it back to Zach.
Thank you, and I'll hand it to the co-hosts.
Amazing. Thank you so much, Micah. And I thought Ron saved me money, and I thought you were helping me with the SREX on my project. Little did I know the history. Amazing, amazing history, and even better current history with the students. I am so fond of this program, and I really enjoyed the pictures that you shared of the students. I have a quick question for you before we hand it off to Zach. I noticed that 3 of the schools that you work with in Solar States were Bryn Mawr, right? And Youth Build, and then the Ben Franklin School, which was the ribbon cutting that you just did, which is amazing. And those are really, really different schools, right? So for folks who don't understand Philly, Youth Build, these are kids that already want to build. They're already committed, right? Bryn Mawr, they're already on a college track usually. And then Franklin is, you know, I don't even know what their focus is, but it might be neither of those. And so I'm wondering what your experience was and how the kids responded and what kind of follow-up you got from the students. Was it the same across the board because you're dealing with kids? Or was there a lot of different influences there?
No, that's a great question. It's hugely different school to school. So, you know, at Ben Franklin, this is an inner city school that's struggling. We also did, actually very early on, I did some training at Science Leadership Academy. These students are college bound. It's a very different experience, you know, and you really have to understand the students and talk with them before you start going into your lesson plans and everything to make sure that you have a plan that's going to meet them where they're at rather than them trying to meet you where you want to be at. It's really a challenge, but also what makes this interesting. It's not one size fits all. And that's one of the beautiful things about our curriculum is you could go through it week, you know, 1 to 2 million, and that works well. Or you can cherry pick sections out if you want and do what works for you. We try to have in there stuff for advanced learners as well as beginners, so that as you're looking through this, you can, you know, sort of pick what works best for your student population. If you don't have a mock roof, can you set up just a flat area in your room and do a flat roof system? That sort of stuff. If you don't have access to batteries or this, can you do this other thing over here where you have an electrical demonstration station instead? You know, so finding ways of meeting students where they're at is absolutely critical to the success. And I got to say, I want to give another shout out to Jordan Crowley, our teacher at Frankford High School, because he's really understood that, you know, I used to think if you have this great curriculum and you have great content, well, then anybody can teach it. But man, once I started teaching, I realized, oh my goodness, you really have to bring the excitement to the classroom. If you're not there, if you're not excited about the content, if you're just reading it right off the list and saying, okay, you put screw A, lag bolt A into joist B, and this is how you do it, everybody's going to fall asleep. But if you connect it to their lives, if you let them know that there's careers here, that there's money involved, that you could, you know, really launch an innovative new product, that, you know, everybody is interested in this field, then it changes the whole learning dynamic in the classroom. So it's really a lot about saying, hey, here are the resources you're going to need, but bring your energy and meet the students where they're at.
Beautiful. And also offering them a niche, whether it's the installation or the sizing or the selling or, you know, another piece of the tech, right? Mark,
absolutely.
Sean, Kevin, what do you guys think?
I just love that where you talked where the kids are on the roof, they've installed the solar panel, they're looking at it, and then when you say, "Hey, turn around," and you say, "There's your opportunity." To me, that is just meaningful, and I want to take what you just said there and apply it to some of my teaching, because you've got them focused, you celebrated, and then you turn around and it's like the world's your oyster, kids. Giddy up. Just great. That's my takeaway. Over to you guys.
Yeah, Mike, a great job. Your passion for teaching is really what's needed in the industry, and I love how you fold in EAC in Philadelphia, their weatherization background and their BPI training, building on that. I think it's going to be great. We fold in Passive House into this and bridge the gap between weatherization, home performance, and get that top tier to Passive House, and we'll really be making an impact in the world. And somehow, if politically we can figure out how to use what are the pace loans, I think would really change our industry, both on the efficiency side and on the solar side, because it was designed to make the green economy a lot easier. So I'm hopefully you guys can lead that way, and then we can all lead. I love your hands-on approach. It's great. It's what's needed, and we need opportunity for younger people. I was a high school student once, and not a very good one. And my wrestling coach took me under my wing, and he said, "You really got to learn, like lead and learn." And without him, I wouldn't be where I'm standing today. And hands-on learning in my craft as a fireman, but also as an insulator and as a trainer, is really how you connect people. And I love how you flip the script on them and made them do the work first. It's really innovative. It's cool. Thank you.
Thank you so much. And I just want to say, the other really unique thing I think about Solar States is we not only do training, but we do the installation work. We're a 40-person full-time company growing, and we had a really neat experience recently. So we installed 2,000 solar panels on the roof of Yards Brewery at 5th and Spring Garden here in Philadelphia. Incredible project, lots of great partners. And we had, I think, 4 people who had just come through our program who were working on the roof, and we got to bring our classroom up there to tour it while it was being installed. And they got to see these 4 people who, but 3 months ago, were in their chair. They were literally in their seats out there working, and they got to talk with them and say, "Hey, you were sitting where I'm sitting now. Like, how's it feel to be on the other side?" And just hearing the conversations and the networking that was going on, they were people exchanging phone numbers. Okay, you got into this industry, you met this person, you met that person. Having that connection, I think is really, really special. And we've seen our students come through, and we've had them now for 4 or 5 years. They're getting their own electrical licenses. They're also moving to other companies. It's one of the things I'm most proud of, is what I call the Solar States Alumni Network, where we now have people all over the industry, all over the United States, who have worked here and are networking with each other to bring them, bring more students into the industry. So I think that's really unique about our particular model, is that we're not just about training, but we're about doing the work as well.
Micah, I have so much to say, but first, total gratitude to you and the program. You're obviously welcoming these young adults as professionals. That example alone allows them to take up the challenge, and the structure and the challenge you provide, it has to travel like wildfire. So bless your heart. We have more to add to that, but I'm looking at the time, and there's a guy with Christmas tree lights and a beautiful gray background named Zach that has so much to share with us.
All right, I'm going to start by thanking our sponsors who make all of this work possible here at the Passive House Accelerator. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsors are Icon Windows and Doors and SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Also, thank you to our patron sponsors, Aero Aggregates, Aero Barrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Euroline Windows, Innotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and U.S. Engineered Wood T-Stud. So thank you, sponsors. On the podcast, we have an interview with co-host Matthew Cutler-Welsh and Joseph Leith, who's a CPHC and architect in Auckland, New Zealand. He works with Respond Architects, and the interview is about the passive house that he designed for his family in outside of Auckland. So it's a great conversation. It's actually part two of a two-part series. The first part was on Homestyle Green, which is the other podcast that Matthew Cutler-Welsh has been doing for many years. So you can, there's a link in the Passive House podcast episode listing to that original episode, and you can listen to both of them. We're also still unveiling great conversations that we had at the FIASCon 2021 conference. So the most recent is with Ilka Cassidy of Holstrom Systems, also a frequent guest co-host of the Passive House podcast. So please check those out. I think we're up to 10 now, and we have a few more coming. Tomorrow, the Global Passive House Showcase will feature Alan Gibson of GeoLogic, and he'll be talking about challenges and solutions in custom passive house panelization at the showcase. So please join us here on Zoom at 7 p.m. Eastern, 4 p.m. Pacific tomorrow for that. And then on Thursday, don't miss this special Passive House component spotlight with Glavel. So we're going to be hearing about foam glass solutions for Passive House. We're also going to be getting a virtual VIP tour of Glavel's brand new factory. So that is at 10 a.m. Pacific, 1 p.m. Eastern on Thursday, and I will share a registration link in chat in just a moment. Next week we have uber great fuck-ups, but it's spelled with a PH, so it's okay. And this is with Cy Safi, and he'll be talking about the Louisville, Kentucky Commercial Passive House Project. Cy is an amazing practitioner and a leader and community member, so you won't want to miss next week's Construction Tech. And finally, we have a Green Schools Project fundraiser that I would like Mark to share about.
Awesome, Zach, and I can't wait for Thursday and that uber great. So speaking of green schools and Giving Tuesday, many of you know I work with Illinois Green Alliance, and they have a green schools project. So the first year was during COVID, and they had 10 schools involved. This year, entering the second year, there's now 32 schools involved. What that means is there's 66 educators, 676 students, and 25 mentors. So there's a link from Zach. If you guys would like to donate, it is a nonprofit. It's been around for about 20 years in Chicago, but this is specifically for the Green Schools Project. And I'm happy to share with them tomorrow the video from tonight, because this is where it's at. And over to you, Sean.
Sorry, I got just mesmerized by all this great stuff, the stuff we've got coming up, but also just Micah's presentation. So that concludes the first portion of tonight. Again, lots of great stuff. We've got to dive into questions. So if you do need to leave, again, you always got homework next week. You got to find a friend, bring them on, make sure they're aware of the excitement that the presenters are going to bring. And again, tonight was no other. So Micah, thank you much for doing that. And just to plant a little seed, we've had little rumblings of this experience, Passive House experience. It's coming in January. Pin it. It's coming, folks. Lots more information coming. We're dreaming it up. We're thinking about it. We're figuring out how we can make this one of 2022's exciting things to be involved in. So Micah, we got questions for you. Again, everyone, if you do need to leave, we love you. We appreciate you, but stick around. We got more coming at you in the overtime.
Thank you, Sean. Welcome to the overtime, everybody. Thank you for hanging out with us. Thank you, Micah, for that presentation. Fantastic. Thank you, Zach, for giving homage to our sponsors who we can't do this without. You are our bread and butter. We love you. And I really am excited about the Glavel piece again. Now that we can all order it and get it, I'm super excited about that. So back to your presentation, Micah, I really thought it was interesting because I was surprised to see how much you emphasized the training program whole building efficiency, right? I kept thinking, oh yeah, they're really going to just keep zeroing in on solar because there's so many avenues, even if you stayed focused only on solar. But as Passive House people, we are so excited to have the ability to go all electric and give solar that leg up by reducing that need in the first place. As you say, sip on the electricity, don't guzzle it, right? It's almost like Miss Manners, you know, have your table manners. Just sip, don't guzzle. So I appreciate that. And I'm going to invite everybody, if you've got a question for Micah, throw it into the chat. Right now, we have one from Barbara in Oz. Barbara, are you still here? You are. Hi, Barbara.
Hiya. I've been trying to find the Christmas lights. It won't let me add them on the filter. So you're just going to have to imagine Christmas lights. Sorry. That was a great talk. My mother used to be a high school principal in New York City, and she was the principal of a school called Murray Bergstrom High School for Business Careers. They might be worth approaching. My old high school, Bronx Science, we have a greenhouse on the roof, nice flat roof. Bronx Science would be worth trying. And then the two schools like on either side of us, DeWitt Clinton and Walton. DeWitt is boys only and Walton is girls only. If you could get up to New York, that would be awesome. Awesome. Anyway, my question, thank you, was disposals, hazmats, and ultimate disposals of PVs. Do you go into that at all?
Absolutely. Recycling is a big issue in the PV industry. And unfortunately, we haven't gotten to the scale yet that we need to. But we have, so we're part of a national cooperative of solar companies. I'm not sure if everybody's aware of this, called Amicus. And Amicus is really an amazing cooperative. We have solar sister companies in pretty much every state around, and we banded together. And one of the Amicus folks, Amanda Bybee, I believe, has started solarrecycle.org, something like that, where we're starting to make inroads on recycling. And there's been a number of recyclers actually who we've worked with. So when we've decommissioned systems, we have recycled the solar panels. That's a big issue though, because it's not happening as much as it should. And people frequently come to us and say, oh, I've got these 10-year-old solar panels, but I want the new ones and I want this. And I keep thinking to myself, but they still work. They still work. You can still use them. They're like, oh, but I want to make more power. I want to do that. And, you know, I never want to discourage somebody from making more power. So we try to find homes for old solar panels. You know, as much as possible, but it is an issue, and we talk about that. You know, there are a lot of highly recyclable materials, the aluminum frame, the glass front, the silicon, but there are some other, you know, small amounts of toxic materials in there as well that need to be handled with care. So I think as solar scales up, you'll see a much better business case for recycling, and I'm very hopeful that we'll see that. And we need to frankly see that for batteries as well, that we get to lithium recycling and that sort of stuff sooner rather than later. And then on the flip side, you know, Amicus was really instrumental in highlighting, at least for us, the solar manufacturers that had problems in their supply chain, that were using forced labor in their supply chain. And we immediately stopped carrying their products, and we said, you know, we're not going to do that anymore. So making sure that, you know, we have cradle to cradle, end to end coverage here, that they're made in the way that they should be made, and that they're recycled in the way that they should, is going to be critical to the success of the industry for sure.
That's fantastic. I love the fact that you cite cradle to cradle, because that's one of my gospels.
Mhm.
Is there a list of manufacturers who are using forced labor? Is there someplace I can find that information?
Yeah, I believe there is a list that Amicus had. There were several manufacturers, unfortunately, mostly in China, that we had seen. I believe that Jinko Solar appeared on that list at one point, and Trina. I can see if you send me an email, I can see if I can dig up the list
Great.
that they sent around.
Thank you. Appreciate it. Take care.
Thanks.
Thank you, Barbara. Great question. I'm on the Amicus website. I threw a link into the chat. I'm looking at their public benefit report right now. So thanks for connecting us there. And it's true to form that your mentor is Ron Celentano. He is so great. We had him on last week and he was pointing out that when you recycle or when you reach the end of life for any of your other appliances, you have the same questions, right? So it's not like a solar panel is so different from any of the other electronics devices that we're using. And in many cases, they last longer. But you just gave me this vision, because when I drive around, much to the dismay of my daughter and my husband, I see things on the side of the road that are still perfectly fine. And I think, well, we could just pick that up and take that home, or maybe we should take it to the thrift store. You know, it shouldn't go in the trash. And I'm just imagining, wow, maybe there'll be solar panels out there that I can trash pick one day because someone wants a new one, and the old one's still good and it's just sitting right there. I can just pick it up and put it on my roof. So maybe there's some hope there that we can recycle and pass on and pass down our panels. I would love that, because in many circles, if it's not broke, don't fix it, right? So thank you for showing us that perspective as well. I don't have any more questions in chat, so if anybody's online and they want to throw one out there to Micah, feel free. But before we do, I'm going to hand to Sean next, because Sean's got a question.
Yeah, a bit of a nerdy question, just because, again, and it's like, I think it probably is in maybe week or 7. So I really should start off at week 1 and work my way through it until I get to week 7. I'm going to skip a couple weeks and get into it. Now that we're getting to, again, more high performance buildings, so our energy loads are low, we're looking at lighting. I just keep thinking that certain systems in our house should be running on DC, and then some of them run on AC. So should we not be looking at lights being running on DC? This is a bit of a big question. You can scale it down or let it go long, but I just, with some of the things you point out where I'm just I keep hearing about these concepts. I don't know of enough, but when we're starting to make those plans, it's hey, should we not just be running certain systems on the right system and not the old system or the incorrect system, and tell one of those Tesla or anyhow, I'll let you dive into it. I got carried away there.
Yeah, sure. I mean, this is a huge question, right? I think it goes all the way back to Tesla and Edison and the current wars, I think there is becoming a bigger and bigger case to be made that we should have DC loads in our house. I mean, you look at things like LEDs. They're really a DC load, and you have to have an extra component in order to make them AC. Any battery that you're charging, heck, the laptop that I'm talking on right now is really a DC thing, and there's a power block that's kind of doing the magic of changing our AC to DC. So there's a lot of extra waste. And when you think about energy, anytime you're doing that inversion of AC to DC or DC to AC, you're losing some power along the way as well, right? You're losing a little bit. The idea that we should be thinking about converting our houses to DC is the right idea. Now, right? If you're on the bleeding edge, you might bleed a little bit, right? Because we're not quite there yet, is what my research has shown. When you go out to the New Mexicos and you see these Earthships and they have all these LED lights and they have DC refrigerators and all of that stuff, it's really cool. That stuff is hard to find on the mass market. It's harder to put together, and sometimes it can, cause some headaches for your architects or designers when you're, putting this stuff together and maybe trying to make a home that isn't an Earthship, but more of a row home in Philadelphia. That said, I think it's the future. I really do. I think that eventually our grid will switch to DC. I think that we're going to eliminate a very expensive component to solar, which is the inverter, because you can just direct DC feed the house. I got to bring up a little pipe dream that I've had for a long time here. I live close to the Ben Franklin Bridge here in Philadelphia, and there's what's called PATCO. It's a high-speed train line that goes over the bridge, and I'm watching it every day, kind of going over the bridge. And I think to myself, that's a DC powered line. Like, we should be feeding, and we did a project for SEPTA, the Southeastern Pennsylvania Transportation Authority, where we put solar on top of a big trolley depot, essentially, right? And we inverted to AC so that they could use it in the building. Meanwhile, they have this DC infrastructure there that we need to start thinking in these ways. How can we directly feed DC rather than switching it over to AC and using all of the energy that way? So I think you're thinking along the right lines, and eventually the products are going to be out there that sort of meet that need.
Great, thanks again. Great stuff, great answer. And we should have had our friend Derek, who's usually joins us on Wednesday nights from China. He would have loved this this presentation, and I can't wait to see him next and be able to send it to him and say, "Hey, you missed a good one." So thanks again for what a great question.
Yeah, no problem. And I'd like to give a shout out to another mentor of mine. Her name is Judy Wicks. I don't know if you folks know Judy Wicks, but she's big in sustainability. She started a wonderful cafe called the White Dog Cafe. She's not only a mentor, but she's a client. She's one of the first people that I know who said, you know what? I'm going to fully electrify my house and go solar. I'm going to do this zero carbon lifestyle. And she just did it right in downtown Philadelphia. And it was a pretty amazing project to see. And, a lot of the stuff we talked about there was like, okay, can we find the right DC refrigerator or this stuff? And we couldn't. So she ended up going with a lot of AC appliances because we couldn't find the right size and form factor and all of that for her particular situation. But Judy is a real pioneer, and she's been about energy conservation and fair food practices for a very long time, and a great person in my life, and definitely a mentor.
Great stuff. I hope everyone saved the chat, because there's been some great links in there. So if you haven't done yet, hit the save chat button so you'll be able to keep all this good stuff.
Mike, I have a quick question.
Go for it, Kevin.
I've always, as an energy nerd, is there a whole house energy monitoring system that you really like that meets the needs currently right now?
Yeah, totally.
Such a good question.
Yeah. So more and more we're finding that our inverter manufacturers are integrating full house energy monitoring. So Enphase comes with a very simple system where you just wrap CTs around the mains coming in, and so you can see all of the energy your building is using, and then you can map that in the online monitoring to the solar that you're generating. And then if you have battery storage, you can map that to what the battery is putting out. And so you get these really cool graphs that can show you all of the data of when you're sucking power from the grid, when you're feeding it back, when you're releasing energy from the batteries. It's really, really neat. But if you want to get more granular, I actually just discovered a system called Emporia, Emporia. It's like $160. You can get it online, at most places, Amazon, wherever you go to shop. It's a set of CTs that wrap around your mains, but it also comes with 16 other CTs, so you can individually monitor circuits. It's pretty simple to set up, and I really like it. Now, because it's $160 and it's not like some of the higher end ones. There's definitely a lot of higher end ones out there. SMAPE comes to mind, SMAPEE, or Sense. I believe Nest might have something coming out. But what I like about Emporia is it's really, basic, no bells or whistles. It shows you the power and energy that each one of your circuits has used. You can see the amperage, you can see it graphed, but it's not like the most fancy interface in the world. But it's a very affordable system, and it's relatively straightforward to install. If you're not comfortable around electrical circuits, please hire an electrician to install it. You do have to go into your main service panel there. There's dangerous stuff there. But if you're comfortable around electrical work and you know how to safely open your main service panel, it's really not difficult to wrap those CTs around and hook up the little box for the monitoring system for Emporia. Yeah, CT stands for current transformer. Thanks, Shannon. I start throwing out acronyms and it'll never end. So, CTs measure current that is flowing through a circuit. And so that gives you a good idea of the energy or power that a circuit is drawing. And that brings up another interesting issue. When we're sizing batteries, this has been a big thing for folks. When we're sizing batteries, a lot of companies out there are saying, well, let me see your electric bill. Okay, you use 10,000 kilowatt hours a year, you use 7,000. Okay, you need this size battery. And that's really not a great way of sizing batteries. We're going to start going around and recommending that folks install an Emporia for a couple months at least prior to us designing a battery system, so that we can have the data that's needed. Because it's not just about energy, right? It's not just about power times time, but it's also about your peak draw, because the battery has to meet that power requirement and the energy requirement. And you really don't see the power spikes. You can't see them on your electrical bill. So you need to have these systems like Emporia in place to make sure that you've sized the battery system properly.
Mike, I fully agree with that. I've always felt that there is almost like a need for an electrical energy audit. We do really good work in BPI and weatherization of doing an energy audit of the building and the performance and gas leak and combustion safety testing, but we don't do a very good job of tracing down that electrical efficiency, those vampire loads. Like most of our utility programs are like, oh, we'll just change out your light bulbs, give you a smart power strip. And they're very good for them, but the end product of finding those energy hogs, it's I think you need to dive down deeper. I purchased the Sense a while ago, and it was a little the feedback wasn't as good. They kept changing their software. It might still be at my place, but
yeah. And you learn really weird things. Like you learn that when you turn your garbage disposal on, one of the things I learned is like the draw just jumps right up. Certain toaster ovens can really call for a lot of power all at once, and so you learn all of these unexpected things when you start monitoring the power and energy usage of your house.
Yeah, the Europeans have a much greater grasp of power usage and when, because they get bills based on the demand and the peak load. Like when I was in Ireland taking the Passive House tradesperson training, Tomas's big story was like, well, you only make your hot water with the immersion heater at night, because during the day it'll cost you an arm and a cow. And I'm like, what are you talking about? And they know it very well. Like checking into an Italian hotel, you put your key to the room in the room, and it shuts all the power off into the whole house. I'm like, they really get this because they pay the real cost of energy.
That's a great point. I got to say, the real cost of energy, the way we've been billing for energy, particularly in the state of Pennsylvania, is just insane. It's like one rate all the time, no matter what. And that's just not how energy is generated and how costs are actually laid out. There are peak times, and we know this, like from 4 to 6, when everybody comes home and turns on all their stuff. There's congestion on the grid. This is a big problem, right? And it's one of those problems that we can either just keep building more power plants to solve, or we can deploy batteries and do like lots of small smart systems throughout that shave that peak down, that get it a little bit lower, and we can make rate signals, time of use rate signals that say to people, turn stuff off, so we stop congesting the grid, so we stop having to build all of this infrastructure. And we need that sort of stuff. And that comes from good federal policy, in my opinion. We need to have a federal guide to how we're going to build the grid of the future, not something that's so heavy-handed that says it has to be this, it has to be that. But it's something that says, listen, we need to relieve congestion during these times. There are lots of different ways we can do that. Here are renewable solutions to this, and battery-based solutions and other storage solutions, things that we haven't even thought of. And then we need to incentivize innovation in those areas as well, to say, hey, we want to start, with these crazy projects, that nobody's ever thought of. I just read a wonderful book called The Fifth Risk by Michael Lewis. And in it, he talks about how incredible some of the ARPA funding programs were for energy. Like, they were just amazing. But the only one that everybody heard about was Solyndra, the one that failed, right? There were 60 other projects, energy efficiency and renewable energy projects that got funded from the government that were huge successes. But we only heard about the one failure. And he makes the argument, he says, listen, if the government had been a venture capital firm, anybody would have taken that portfolio. They would have said it was an amazing success, but instead the program got cut because one business went under. So we need to start taking risks. We need to say to the government, it's okay to take risks in funding new and interesting research in this area, because it's what we need.
Hey, Micah, that just reminded me of a really cool project here in Vancouver that just got announced middle of last week. You buy a Passive House, this particular condo unit, they're giving you the battery, they're giving you a Tesla Model 3.
Oh, wow. That's awesome.
I'm moving. That's it.
Moving.
That's the end of it for me.
That's it. Hey, that's it. Everyone come join us. We'll hang out at this Passive House. Now, I'm working on them on the envelope, though. They're choosing some higher embodied insulation, but we're working on it. At least they're, hey, baby steps. And you said, right, success stories. We got to praise them for what they're doing. So that came out middle of last week, and I was like, we got to talk about that next week. So because I know again, Tim McDonald, with all of his projects in Philly, that's he's been waiting for. He's been waiting for those car batteries to be cheap enough to replace the batteries, and he's just going to be like, here you go, here's your battery, park it in the bottom floor.
I'm so glad you said Tim McDonald. There's another real innovator and mentor of mine in the field. I mean, Tim has been doing this for a very long time. As I like to say, he's been passive aggressive for a very long time. So I
met Tim at the tradesperson training I took out in Ireland, him and his brother Patrick and his partner Howard. And you could just tell he just had the drive to change the world a little bit. And it's been great to know Tim and see all the work he's been doing. He's an awesome dude.
That's great. He's an awesome dude. And so that Crane Arts project that I showed you when we're up on the building, Patrick and I and a few other people did that together. That was all us working together. And he's the only person that I know of to this point, at least on the East Coast, that has wrapped an entire building in solar panels. I mean, he said, forget about the roof. Let's see what the entire building, I think it's called the Bank. It's a building here.
Battery.
The battery in Philadelphia. And it's just an incredible looking structure. And you think about it and you say, why not? Why not? It's really cool. And he had to fight tooth and nail from L&I licensing and inspections. They're like, wait, you have solar panels on every side of this building? You can't do that, But Tim, he just has this thing where he's like, this should be done, and I'm going to do it. And he goes out and he does it. It's really inspiring. And their crew at Onion Flats are just amazing. So big shout out to Tim McDonald and his team.
Well, and your mentor was designing those and they were installing them. He presented on that last week. So if anybody missed that, please go back and take a good look, because you'll see not only how they designed and installed it, but what they had to do to get there with all of those micro transformers as well. Mark, you had a question for Micah, I think.
I got questions, I got statements, I got praise. Kevin's questions were really perfect. And so I got really caught up in those questions. I wanted to say with this program and the receptiveness of the students, my first starter question, right, because there's always a later question, is how did the districts and the community first respond to this coming aboard so that it could be possible?
So your question is the districts in Pennsylvania, how did they respond?
Yes.
So the answer is we don't really know yet.
Okay.
We've been spending the last couple of years writing the curriculum, getting feedback from the classroom, and sort of tailoring it. So we're going into the graphic design stage now. All the content is done. We've sent it over to the graphic designer. They're going to sort of pretty it up, and then we're going to release it out and take feedback from other schools around the state. So I don't know yet, but I'm very excited to see what people have to say, because as much time as we spent on it, and there's been lots of people with, hands in the pot, adding to it, lots of great people, it always gets better with the more input you get from other folks out there. So, I'm sure there's some innovator out in Erie, Pennsylvania, who's going to look at this and say, oh, but you forgot this thing. And I'm going to say, oh, of course, let's add it to it. Let's throw it in.
That's perfect. My statement to that, and Shannon will probably follow up with this offline if you're not always connected, is Michael on here seems like a great contact. And I don't think Michael's here tonight, Shannon.
He was, but he had to hop off. Yeah.
Okay. So if Micah and Michael haven't spoken, we should put that together. So my next question, Micah, is other states, right? If you could give us a bird's eye view of how your work can accelerate, right? Right. This is the platform we're all in front of. And how can it accelerate? And is there an ask of any of us to help share that?
Absolutely. So, we're all familiar with the infrastructure bill that just got passed, and now there's the Build Back Better bill. If we can get that passed with the current incentives that are in there for solar and renewables, it's going to be transformative for the solar industry. And there's really one big piece of it that I'm super excited about. So as I said, I got my start way back in 2008, 13 years ago. The reason I started in the solar industry, I saw Van Jones, but also Obama got elected, and he changed this 30% federal tax credit to a cash grant. And I was just a kid from the streets of Philadelphia. I had no tax liability, but because he changed it to a cash grant, I was able to use that cash to build the solar system that involved Pat McDonald and Tim and all those folks at the Crane Arts building. Okay. Since then, it's been converted back to a tax credit only. And, we've learned how to use that, but there's issues when something is a tax credit only, in that a lot of poor people can't utilize tax credits. So it leaves a lot of people out, unfortunately. Well, as part of Build Back Better, you can take it as a tax credit, or you can get it refunded as cash. That's huge. That will be transformative for the solar industry. So supporting that aspect will accelerate solar throughout the entire country. There is no doubt in my mind about that. The other piece of it is if you know people, or you're looking to go solar, or you're looking for a great consultation, go to the Amicus Solar website. Find the local solar installer that's a part of Amicus. It's really a symbol for a company that not only does great work for solar, but cares about the community. We're what's called a B certified corporation. I'm sure a lot of you folks know what the B Corp movement is all about. There are a lot of B certified companies that are a part of Amicus, and all of them are mission driven. They care about their community, and they're not just in there to slap solar on as many buildings as possible and do it in any old way possible, using any old panel that's out there that may or may not be a good fit or made in an ethical or sustainable way. That really does matter. We need to accelerate responsible companies that are paying living wages to their employees. And by going with a company that's associated with Amicus, you can be sure that you're getting one of those companies.
Thank you so much for that. It seems like a great outline. I filled up my notes 10
Got a
times
quick
what I
question, Mark.
thought. Go ahead, Kevin.
So speaking of the next frontier in Passive House, we always our biggest after we optimize the envelope and incorporate solar, the hot water is always the bane of our existence. What do you think the future of hot water is? Is it evacuated tubes? Is it flat panels, or is it going from PV to heat pump hot water heaters? What are your thoughts?
Sure. I have opinions about many things. I'm woefully uneducated on solar hot water, unfortunately. I can tell you this, it's always been a mystery that, when I've traveled to different parts of the world, solar hot water, like if you go to, places like Turkey or, other countries, it's just ubiquitous. It's everywhere. You see a solar hot water tank on the roof everywhere. And it just doesn't seem to have caught on here in the United States for some reason. I don't know why. I just don't know enough. Yeah, Germany too. Absolutely. There's solar hot water in many, many countries all over the globe. In the United States, not so much. So I wondered the same thing myself. I know it's a very efficient technology. And I remember when I went to one of the solar conferences, Solar Power, I saw a really cool PV panel that behind it had integrated solar hot water. So it was using the heat coming off of the PV panel itself to also heat, I believe it was evacuated tubes that were behind it. I'm not 100% on that. And I thought that was really cool, but then I never saw that again. And that's sort of similar to now we're seeing solar panels that are coming on the market that have integrated batteries, right? Like, wow, I would have never guessed to see that, right?
Very cool.
So the answer to the question is, unfortunately, I'm woefully ignorant with solar thermal technologies. I wish I knew more.
I appreciate that, Micah. I personally have been a fan of solar hot water, and I feel that it's, in order to install a system, it's very engineer designer based. So you're relying on your engineer to create you a kit of parts. Then you're going to have to get a plumber and then an actual solar installer to install it, as opposed to going to a manufacturer that sells everything you might need. I think if we can get some of the bigger manufacturers more bought into the market, Viessmann, Wagner, some of those European-based systems to sell here and sell them in, I hate to say it, but inch-pound sizes, we'll have greater adaption, because and code enforcers really don't like to see us borrowing from Europe and installing it into their plumbing system.
Right.
Our heating water design is, I think, as Gary Klein said, from the 1940s. So a lot of things need to be updated. So
maybe when Micah's out there helping these kids understand how to install the panels and be solar suave gurus, teach them the metric system.
We do. That's a big part of it. I mean, you can't talk about kilowatts and kilo without knowing the metric system. So absolutely, that's super, super important.
Well, thank you so much for going into the monitoring, because we also talk about the hot water being the bane of our existence, but also we do all this work to create these zero energy buildings. And then often monitoring wasn't part of the owner's requests or the priority or a requirement. And so we lose that opportunity to prove what we just built, or to troubleshoot some of the technology that we've installed. And the monitoring gives us the power to do both of those things. So I know that Ron is a big proponent of both of those in the single integrated network, but FIAS and the Passive House certifying bodies are starting to look at this peak versus off-peak piece and the microgrid and nanogrid piece. Do you do any of that in your education? And then my second question is, what advice do you have for people who want to steal your idea and apply it where they are? What is the kernel of truth that's going to help them integrate with their schools? Because that is really hard to do when teachers are so flat out to begin with, and they're really working off their lesson plans just to get to the finish line between summer and the next year. So Two completely opposite questions coming at you, Micah. Sorry about that.
I'm going to start with number 2, and then I might ask you to repeat number 1. So number 2 is, one of the interesting things I found about teachers is, my God, teaching is hard, right? I mean, you've got to come in, you've got to be like on all the time. You're there, you're essentially presenting and trying to incorporate students into getting into learning and getting hands-on and getting motivated for 6 hours a day, 8 hours a day. It could be even longer, That's an incredibly hard thing to do. People think that teaching is just, oh, anybody could do it, right? No, teaching is a real vocation. But here's one of the things I realized is teachers are always looking to take a break because they always have to be on. So if you can come in and you can say to them, hey, I can present to your class. I have this thing that I think would fit nicely into what you're doing in science or in math or whatever it is, and try to be cross-disciplinary about it, because that is important. If you can give them really unique content where you can deliver it and allow them to have a little bit of downtime, boy, I haven't met many teachers who are going to say no to that. They want to be able to have a break, to catch up on grading, to do some more planning, and that sort of stuff in their classroom. So that's how I would approach it, is come and speak with the teachers.
And
For a
you
long
said it
time.
took 3 years to get integrated into the programs you're in.
Mm-hmm.
When someone's trying to copy this idea, is that long view, a 3-year view, kind of a requirement for getting into the curriculum? Or do you think that there was something exceptional there? You look like you have a young student right there.
I have my own little student here. Say hi, Mira. Mwah. Hi. Metal teeth. She got some fillings in today. Oh, there it is.
Congratulations. Wow, that's a solar smile if I ever saw one.
So yeah, I mean, the Philadelphia School District is a frustratingly bureaucratic entity, right? Very, very large. I started something years ago called the Philadelphia Solar Schools Initiative. And I thought, I was like, 13 years ago, I was a lot younger. I had all this passion. I was like, why doesn't every school have solar on it? I'm going to put solar in every school. We're going to make it a learning experience. These are all learning experiences. Like, there's so many schools out there, so many roofs. We're just going to go do this. And I ran into this just beat down at the bureaucracy of the district. 3 years, I was trying, why isn't this happening? Why isn't it going? Come on, guys, who's pushing for this? And they're like, oh, we got so many other concerns. We've got violence in the schools. Now we got lead in our water pipes. Now we got this. Now we got that. I mean, they were putting out fire after fire. And I had to, come to the realization that, unfortunately, they could not handle the crises in front of them and start preparing for the future. And despite the size of the bureaucracy, they just didn't have that capacity. And so understanding that and saying, okay, I need to step back. What can I offer? What can I bring here where they just can't say no, And in some ways, I had to say, you know what? I'm not even going to go and talk to the district anymore. I'm just going to go right to the teachers. I'm just going to talk with them directly rather than talking to the district. And I'm going to see what they need. And that's where I saw a lot of success, because they immediately were doing what I just said. They're saying, oh my gosh, you have something to teach. You have this course around solar and all that. Come on into my classroom, because I need to fill some time. I need to make sure that they're learning about this stuff, and I'm not the expert on it. And I would love to have some time where I can catch up on things. And that's where I really saw things taking off. So to anybody who's interested in doing this, I suggest a bottom-up approach. And now, guess what? Now the teachers are pushing the school district to go solar. So we may actually, 13 years later, the Philadelphia Solar Schools Initiative may start having legs because the teachers are pushing for it from the bottom up, rather than me trying to go to the district and saying, let's top down this thing and get it done right away. All right, so back to question 1. Remind me question 1.
Oh, it was about microgrids and nanogrids and the whole off-peak piece and getting a more of a community scale. But
Interesting,
We also have a
interesting.
question from Bob in Chicago after me. So Bob, you're on deck.
Okay, so microgrids are, obviously the future here. And there's, people say, can you define a microgrid? It's like, if you can operate without the grid at large, it's kind of a microgrid, right? It could be one house, could be two houses, could be a whole neighborhood. The Enphase systems that we're installing are really house-based microgrids. They're able to form a house-based microgrid by having a battery in what's called an MID, or a microgrid initiation device, where you can isolate yourself from the grid at large and then generate and use your own power. Okay, so that's really interesting. Now, there are also, larger battery packs that could be community oriented. I personally haven't rolled any of these out, but I've seen larger warehouses and other style businesses that we've installed battery systems on that could act as sort of community resources should there be a power outage event. So I think it's coming, where you see sort of neighborhood scale battery packs that are going to go around. I just haven't been involved in the installation or design of any yet.
Thanks, Micah. Bob, would you like to come on and unmute, ask your question?
Yeah, I'd love to. Thanks a lot. But it's a great presentation, by the way. Talk about pushing the ball forward. So I am always interested in the nuances of installation. You're putting solar panels on roofs, and you get a variety of metal roofs and shingle roofs and, low slope and so on and so forth. So what about the detailing of attaching a solar panel to a roof? Is that part of the curriculum?
Oh, absolutely, absolutely. So that's another big change in the industry since I first started. So when we did the Crane Arc solar installation, I would say there was probably 75 parts that we had to all keep in order. That was a bit of a nightmare. And now it's down to probably 20 or fewer parts when you're doing a solar installation. And there are specific parts for specific roof styles. So for example, standing seam roofs, you can say, oh yeah, we can install solar on a standing seam roof, but a standing seam comes in how many different profiles? I mean, there's 1,000, right? Infinite. It could be a ripple, it could be a seam, it could be have a mushroom head, it could have this style head. But the wonderful thing is there are companies out there. I'm thinking of a company called S5. The S5 clamp, they've designed clamps for these standing seams that can basically meet any profile that's out there. I have yet to meet a profile. Same thing with tile roofs. I'm in Philadelphia. I don't install much tile roof stuff, but heck, we had a client who had a Spanish tile roof, and there was a product out there called Roof Hook that was made specifically for Spanish tile. And boom, this is how you install it. And it wasn't, rocket science. We could get up there and get it done. So that's really the maturation of the industry, is that there are now products out there that solve for pretty much any roof attachment style you need done. And it's just a matter of knowledge, of knowing that that's out there, right? I mean, it's a lot like the electrical trades. There are so many parts that solve so many different little problems that until you get into that problem and you're like, oh no, what does this? You don't know that part exists. But once you know that part exists, it completely solves everything. And you're like, oh, right. Okay, that was easy. You just have to know.
All together now.
Well, seriously, to that point though, Mike, you've had 5 bomber questions come your way. Is this included in your program? Your answer to every single one of them is absolutely. And
and here's a link where you can find out more. Except for hot water, but I've got to say, it's a strong man that can admit what he does not know, because you know so much, and you've shared so much knowledge with us. You shared a lot of great resources with us, and I appreciate that. We need to have Gary Klein back on and now quiz him on the hot water aspect yet again.
Well, we can ask while Micah's on. Micah, do you know Gary Klein?
The name sounds very familiar to me. I don't know that I know him personally, but the name does ring a bell.
His famous question is, if you turn your hot water on, how long would you like it to take in order for it to be hot?
Oh, I
How
like
many
that, especially in
seconds? And
my
then he
house.
How many
starts
seconds
counting.
would you
Yes,
like
How
it
many-
to
one,
take?
2,
Mhm.
3,
How
4.
about now?
Now, I love it right away. I mean, I love like, I've seen these like instant hot water heaters that are in people's bathrooms too, where it's like right there and it's hot right away. That's so cool to me.
Well, but the
plumbing
same thing
man.
applies, whether that's the whole fun of this conversation, right? Is it might take 6 seconds if it comes from there, right? You just don't know. It's the system.
Right.
So with that though, you said like 6x absolutely's. Is there something that the program doesn't have that you think it needs to add to be another secret sauce, right? Like Coca-Cola is just a soda, but for some reason there's something that makes it a secret sauce.
Right. I think it's the part we haven't gotten to yet, frankly, where it's input from the public at large. We really need to open it up now. We've had it stewing inside, and we really need to get input from a lot of different educators in a lot of different scenarios, because I'm sure as much as knowledge as I have and teaching for all the years I have and being in the industry, I don't know it all, and I don't know a lot of stuff that's out there. And it's always amazing to me when people point out, how did you miss this? How did you miss that? And you're just like, man, I don't know how I did that. I just completely missed it. And, that's always the case. And it's always good to get other people involved. And I want to say that I consider this curriculum, and I really hope this is the case, to be my life's work, that I want to steward this. It is not a dead document. It's not that it is done now. It's never done. It's going to constantly be updated because there's constant innovation going on. And really, I want to make sure that this thing lives on for a very long time and is useful for a very long time. And that, frankly, cannot happen without lots of input. I'm a big fan of open source software. And I think one of the things that makes that so incredible is that a community of people, much like the Passive House community, is coming together to share ideas, to share information. Well, we need that to happen around this curriculum so that it stays relevant. It's not just relevant in this moment.
Can I jump in real quick?
Yeah, absolutely, Bob.
Go ahead, Bob.
First, I have to tell Micah, you're preaching to the choir. I just threw my open source architecture link into there. And Bob, you know what? Hang on to that thought. We did get a question from Patricia while we were waiting. So I'm going to hand the mic over to Patricia just for a moment, and then we'll jump over to you.
Okay, thank you.
Can you hear me?
Yes. Hi, Patricia. Welcome.
Hi. Yeah, it's an amazing curriculum. It's so amazing. I want to sign up. I wish I were like, let's see, 60 years younger. But what I want to know is, how does it take, do the students also take math and English and science, or because it seems so packed with material? I guess that's my question. Is it a regular high school with this? Is just like 2 45-minute classes a day or something that?
Right. So this is a track they're on. So they do have math and English classes, and that's another piece that I want to integrate is sort of these tentacles out to math to say, oh, by the way, watts equals volts times amps. That's your entry to algebra, right? Like, here's Ohm's law as a way of grabbing math skills in. So that's another part where we can really innovate on this. But yes, to answer your question, the students, they'll either spend 1 hour in this class, or they, in the current setup, twice a week, they have a 2 or 3 hour long class. And then 3 times a week, it's just an hour long. So they do have English and math and social studies and all those other classes throughout the day. Mm-hmm.
I wonder if you heard of the name Stanley Muma.
I've not heard of that.
You're in Pennsylvania, right?
Yes.
Yeah, he taught it over on the western part of the state somewhere. He was my mechanicals teacher at ASU, and he was teaching people in the community how to make hot water with 50-gallon drums painted black on the
Neat.
roof, gravity fed. I mean, you can't get much simpler than that, but
That's pretty awesome.
you might look him up. He's got to be
Yeah, yeah.
older now, but Stanley Mumma, M-U-M-M-A. He was big into that back then, which was, at the beginning when we could have made a big difference. But anyway, okay, thank you so much. I appreciate your answer. Great program. I can't wait to see the curricula.
Thank you, Patricia. And last question of the night is to Bob before we jump into our Passive House Challenge.
Okay, real quick though, thanks, Shannon. Micah, next time you have any project going on a low slope roof, if you could keep me in mind, because as a roofing contractor that specializes in healthy envelopes, I want solar panels to be the 2.0 of our work.
Awesome. Will do.
Yeah, it's because we've learned how to develop a very healthy, long-lasting roof, and so the basis thereof is going to be repiping and retrofitting these buildings. So I'll put my my email in the chat if you don't mind.
That'd be great. Thanks.
Cool. Thank you.
Thanks, Bob. And I'm going to hand it over to Mr. Mark Willie, who's going to give Micah our weekly challenge.
Yeah, and Shannon, I'm really, really happy with tonight. The topic, the photos, the energy, the potential for copycatters everywhere, right? The energy that started it off for me, Micah, was the folks in front of the van. You gave his name, right? And he was more enthusiastic than someone a third of his age, right? Pulling up to the van and delivering the energy, the transfer of that knowledge. So that kicked it off for me. The second thing that kicked it off for me is we're starting year 2, and we're starting with a focus on solar, renewables, and education. We couldn't have planned a night to be as well as it is tonight, and with so many familiar faces, and Barbara's contribution to the area and the stuff of growing up in that, to have the substance, the sharing of names and the links tonight it shows you, or it shows us, Micah, and I think it shows you how much community that understands where we need to be is in love with what you're doing. And much respect to you and the students and all who bring it forward. So Kevin's back on. We have a little tradition here, but Kevin.
Thank you very much. I had to go take care of my my teacher upstairs, who's not feeling quite quite up to speed. My girlfriend Megan, she's great. She's a high school English teacher, but she's feeling a little under the weather. But she works hard. They all work hard. Her and all our friends at Newark High School, and hopefully we'll get some Passive House solar curriculum in that building eventually. But they do have their hands full, and it's not an easy task. And you really did. You are making change. You're a change agent in your areas. So if you want to do the tease, so you're going to say what Mark's pointing to there. So you say Passive House Accelerator, construction tech, technical, technology, technique, and I screwed it up, and I'm reading it. So if you can do a better job than me, you're good.
So I have to say Passive House Accelerator, construction tech, technical, technique, technology.
So now the challenge, Mike, is as many cities as you want to adopt this, you have to repeat that many times.
And then you have to kick it off to someone else in the room.
Okay.
So Michael, let's pretend you're on the rooftop with all the kids pointing to the cities that don't have solar. Say the background one more time as if we're on the rooftop with those students.
Okay. Passive House Accelerator, construction tech, technical, technique, technology. Woo!
Who do you want to hand it off to, Micah?
That's
Who's
right.
gonna say it next?
I'll hand it off to Bob in Chicago.
Oh, what an honor. Hey, Passive House Accelerator, construction tech, technical, technique, and technology. Peter Molinar, rocket.
Passive House Accelerator Construction Technical Technique Technology. And this is a wonderful presentation. Give it to Hans.
I knew it was going to come. So I'm going to actually shout it out as if I'm standing on a German roof. And so I'm going to have to shout it out in German, but I'm going to have to read it. So Passivhaus Accelerator Bautechnik, technisch Methode Technologie. Technologie.
Actually, Hans, that you were on mute. Could you try that again?
Yeah, whatever.
Okay,
I'll do it again.
I just have to say that was my favorite one ever.
So Passivhaus Accelerator Bautechnik, technisch Methode Technologie. There you go. And I
Pass it forward, Hans.
That's our first multi-language tease.
Yeah, and I will hear it in Australian from Barbara.
Awesome. Thank you, Hans.
Micah's even got a
Danke
young
schön.
reindeer with him.
Yeah. Awesome. Look, I can't do the Australian accent. I could maybe do it in Bronx, but you're going to get it the way I
Oh,
normally.
perfect.
Passive House Accelerator Construction Technical Technique Technology. And pass it to Patricia.
Her audio may or may not come in.
How about we
Okay.
pass it to Julie?
Okay. Oh, she's gone.
How about Micah's daughter?
Oh, the
Can you
reindeer.
read what's over our shoulder here? Can
Okay,
reindeers
you
read?
it? You read it. Say passive
Passive House Accelerator
construction
Construction Tech Technical Technique Technology.
Yay! Good stuff.
Oh, and that's a wrap. I love it. Drop the mic. Nobody's going to do better than that.
That's it.
Micah,
Thank you,
thanks for being
everybody.
with us tonight.
Micah, that was great. I'm sorry I missed the last little bit, but the spaghetti's good in my belly right now. So
Thank you so
Bye-bye.
much, Micah, and we'll see everyone tomorrow. You'll
All
have
right.
a free pass to the showcase.
Yeah, thank you
Bye-bye.
from the East Coast, the West Coast, Canada, and across the pond. Good night,
Thanks,
everybody.
Barbara. Good night, everybody.
Thanks. Bye.
Make sure you save the chat. Save the chat. Lots of good stuff in the chat
Oh,
tonight.
I'm saving it. I'm doing it now. Save the chat. Show and folder.
Hey, Sean, do you see
Okay.
that car? I hear it go do 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 do.
I'm stopping recording.
Uh,